starting off all the way back in chapter 6, okay, for your semester final, is with slope-intercept form. What is the slope-intercept form equation? Y equals mx plus b. Were you about to say what m equals?
I don't know.
What were you about to say?
What x equals? Vertex.
Okay. So that's going to be tricky, okay, knowing which type of graphs you're doing, whether it's the slope-intercept form or whether it's the quadratic equation forms where you use the x equals. This is slope-intercept, yep, because we look for that y equals mx plus b, okay? On number 1, are they in that form? Yes, they're already in y equals mx plus b form, so we don't have to do any moving, switching, or anything, okay? Notice we have 2 equations, though, so we need to graph one of them first. So where do I start graphing with slope-intercept form? That b, right? What does this b tell us? Or this point right here. What does that tell us on the graph? Where is it at? It's the y-axis, okay? So we find -2 on the y-axis. Are you ever going to use the x-axis for slope-intercept form? No. Always the y-axis, okay? And then how do we use the m, the slope, to help us get the rest of the points? Yep, go up 1, rise over run, up 1 over 4. Can I keep going in that direction? No, so I need to go back and go down 1 over 4. Okay, I can't go any farther, so create your line. Now we need to do the same thing for the other line. Where do I start on this line? At 1 on which axis? Y-axis. And then it's a negative slope, so be careful with that. What do I need to do? Which direction? If I go down? Down 1, right 2. Keep going, down 1, right 2. Remember when we had 2 equations, what was our ending goal? Where they meet, right? So if we already have them meet somewhere, that's what our answer is. Okay, so they meet at this point. They meet at this point right here. So what is my answer? 4, -1. Yep. So wherever they cross, that is where your answer is. Okay? Remember there were 2 other options for answers? So there was a definite solution that we just found. Okay, what does no solution look like? I'm going to come over here. I'm going to draw a makeshift graph. What would no solution look like? Parallel lines. Yep, because why? They're never going to meet nothing. So this one here would look like your no solution because they have nothing here. Okay. There was one more option, what it looked like. We had no solution, we had 1 solution, and we had infinite solutions. What does infinite solutions look like? First of all, what does infinite mean?
Oh, aren't they on top of each other?
Many, right? Yep, they are on top of each other. They're the same line. So if there's infinite solutions, that means they are the same exact line on top of each other. Okay, so there's your 3 different options. The one that we did on the graph, that was 1 solution where they crossed. Okay, and then moving over with parallel lines, they don't touch, so that's no solution. And then the infinite solutions is if they're the same line on top of each other. Okay, because they touch here, 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 everywhere. Okay, that's why they're infinite solutions. Number 3, are these in the correct form? No. Remember, the form that we wanted in is what? Y equals mx plus b. So are either of them in the form? No. So we need to move them. Okay, we want to get y by itself. This is the first equation. How do I want to move it? Subtract x on both sides. So then we have y equals -x minus 3. Is that in the correct form? Yes. Okay. Let's work on that other equation. We have 8x plus y equals 4. How do I get rid of that? Yep, subtract 8x on both sides. So we have y equals negative 8x plus 4. Is that in the correct form? Yes. One thing I want to ask you, if there was a 2 here, how would I get rid of that 2? Divide by 2 to everything, right? Or just 1? Everything. So we're dividing each term by 2. So if it was dividing by 2, we would end up having y equals negative 4x plus 2. So keep that in mind. If there was a 2 there, we would want to get rid of that by dividing to everything, okay? Ignore all of that, though. That's not our equation. Okay? Now, what do we want to do now that we have them in the correct form? We want to graph both of them. I'm going to graph my red one first. Where do I start? Negative 3 on y-axis. Yep. And then what is my slope? Yep. There's technically a 1 here, so we have negative 1 over 1. If I go down, what direction do I need to go? Right. Yep. And remember, with these, you want to go all the way through the graph just in case they happen to cross. Okay, so there's that one. Now we want to do the same thing for the blue one. Where am I going to go on that one? 4 on the y-axis, and then what? Down 8 over 1. Did we just get an answer?
Yes.
Yes. Okay, what is my answer? Yep, 1, negative 4, right where it crosses. So let's talk number 5. Directions say what?
Solve each.
By substitution. Think, what does substitution mean? Plugging it in for each other. Okay, so with substitution, what do you want to look for? Remember?
Same
We want to look,
numbers.
that's elimination. With substitution, we want to look for a variable that's already by itself.
Yes.
Do we have it?
Yeah.
We have y by itself. Okay, so good. We don't have to move anything. We don't have to do anything. Okay, so what do I do with this equation right here, with substitution? Plug it into the other equation where y is. Okay, so we're putting it in right here. So far, so good? Okay, so I'm going to rewrite that equation while plugging in that equation to y. Watch as I'm plugging it in, okay, because sometimes we make this little mistake. Put your parentheses in there, and then I'm literally taking that whole equation and putting it in. So I have 5x plus 7 equals 22. What's the first step I should do when I simplify this? Distribute here. So we have negative 8x plus 35x plus 49 equals 22. What do I want to do from here? Yep, combine like terms here. I have negative 8 plus 35. What do you get for that? 27. 27x plus 49 equals 22. And now it's a simple two-step. What do I do next? Subtract 49. 27x equals negative 27. That ain't right. Last step. Divide by 27, so we get x equals negative 1. Am I done? Why not? Right, we have our x, okay? So we're partway done. We have our x here, but we also need our y. What am I going to do with that x equals negative 1? Why are we picking that one? Why are we picking this equation to plug it into? We just used the other one, and that one has y by itself already. So there's not a lot of solving you have to do. All you have to do is just plug that value in. Okay, so I'm using that first equation, and I'm plugging x in, negative 1 in for x. So we have y equals 5. Now, is it minus 1 or is it multiplying by negative 1? Yep, be careful with that. Plus 7. 5 times negative 1 is negative 5 plus 7, so you get 2. Y equals 2. Now are we done? Yes, we have our x and we have our y. Right away, there is not one by itself. So we need to make one by itself. Which one is the easiest to get by itself? Right, why do you pick that equation? What do we want to get by itself? Right, because there's no number, there's no coefficient with that y. Okay, so I'm going to take that 3x minus y equals 3, and we said we want to get that y by itself. Okay, so how do I get y by itself? Subtract 3x. So I have negative y equals negative 3x plus 3. Is y by itself yet? No. What do I have to do last? Divide by negative 1 to everything, remember? So we have y equals 3x minus 3. Now do we have a variable that's by itself? Yes. If you don't want to forget about it, because I know we get messy and get lost, star it, circle it, underline it, something so that you know what's there. Okay. What was that equation? What are you doing with this right here? Where are you plugging it in at? On which equation? The first one. Yep, the other one. So we're plugging it into that equation right there. So if I plug that in, I get negative 6x minus 2, and then I plug in my 3x minus 3 equals negative 6. Okay, first step, distribute. Negative 6x minus 6x plus 6 equals negative 6. Next, combine like terms, so we have negative 12x plus 6 equals negative 6. Two-step, subtract 6. So we have negative 12x equals negative 12. Last step, divide by negative 12. We get x equals 1. Okay, are we done? No. What do we need to do? Yep, we need to find a y. Where am I going to plug that into? Yep, the one that we found to get y by itself. Why are we picking that one? Because y is already by itself, and that's what we're looking for. Okay, so we do y equals 3 times 1 minus 3. 3 minus 3 gives us 0. Y equals 0. Okay, we're done because we found an x and we found our y. What do the directions say? Elimination. So what do we look for with elimination this time? What does elimination mean? To take something out, to get rid of something. So what do we look for? Right, we look for opposites, okay? We compare the x's and we compare the y's. We want to get rid of one of those, so we're only working with one. Which one of those is easy to get rid of? Why the 10? Because it's the same number, but they're opposites. Okay, so am I going to subtract or am I going to add? I'm going to add them together because they're opposites. So add. What happens to the x's? Gone. Then we have 5y minus y, 4y, and then we have 15 plus 21. 36. And then one step equation, how do I solve? Divide by 4, so we get y equals 9. We have our y, but we want to find our x. So we need to plug it back in. Where am I going to plug it back into? It honestly doesn't matter. Okay, I'm just going to pick the second one because it looks easier. Okay, so plugging it into that second equation, I have 10x minus 9 equals 21. Next, I'm going to add 9. So we have 10x equals 30. Last step, divide by 10, x equals 3. So you have your x and you have your y and you're done. 9. Okay, I'm going to look at both 9 and 10 because they're a little different. Do any cancel out right away? No. What do we do if none of them cancel out right away? Right. You want to make them cancel out. So looking at the x's, can I turn one of them into the other? Which one? I can turn the 7, so we're going to take that right there. What am I going to multiply by? 2. Good. Why am I multiplying by a positive 2? Because you want them opposite. Yep. So if I change this, I get 14x plus 4y equals negative 44. Remember, we're distributing this 2 into all the numbers, not just the 7x. Okay? And then I'm going to rewrite the other equation below. Okay. Do they cancel each other out now? Yes. So that one, we only needed to change 1. Looking at number 10, first C, do any of them cancel out right away? No. Okay, can we easily make 1 into the other? No. So what do we do for the third option? You mean multiply? Yep. So we want to turn them into each other. So do we want to deal with the x's or the y's? Why do you pick the y's? I would pick, it doesn't matter which one you pick, but I would pick the y's because they're already opposites. So you don't have to worry about a negative or anything. Okay? So what am I going to multiply the top equation by if I'm choosing y? I'm going to multiply it by each other. So I'm going to multiply it by 8. What am I going to multiply the bottom one by? 5. Good. Okay, so go through, distribute all of that. So we have negative 24x plus 40y equals, then we have negative 35x minus 40y equals 130. Now do we have them to a point where they can cancel each other out? Yes. So now we can do what we did on number 9. We can add the two equations. Negative 24 plus negative 35 is negative 59x. What happens to the y's? Cancel, which is what we wanted. Okay, and then we get 224 plus 130, which is 354. What is my last step? Divide by negative 59. So we get x equals negative 6. Find an x, or sorry, we want to find a y. What am I going to plug it into?
Either
Of my originals or my 2 that I changed? It doesn't matter. Okay, I'm going to pick one of the 2 that I changed. Okay, does it matter which one I choose? No, which one do you want? This one? Okay, so I'm going to pick that equation and I'm going to plug it in. So I have negative 24 times negative 6 plus 40y equals 224. So now you just evaluate and solve. So I'm going to subtract. So I have 40y equals 80. So I divide by 40. We get y equals 2. Remember, these were the story problems where you can pick if you want to use substitution or elimination. Okay, but these are where you're making your own equations. Pick. Do you want me to do 11 or 12? 11? Okay. So, I'm going to advise. Do you need to read the whole problem?
Yes. No.
No. I call it junk. Okay? You don't want to read junk that doesn't matter to you. Okay? So do I care about any sentence that doesn't have numbers? No. Get rid of them. I don't care about them. Okay? So, Crystal sold 10 rolls of plain wrapping paper and 7 rolls of shiny wrapping paper for a total of $185. How can I write that as an equation? 10 P plus 7. Okay, be careful if you choose S, because what does that look like? 5. It looks like a 5. So I'm going to pick a W. Yep. You could pick S, just be careful. And then what does that equal? 185. Okay, I'm done with that sentence right there. Okay, Deshaun sold 5 rolls of plain wrapping paper and 3 rolls of shiny wrapping paper for a total of $85. Equals 85. So now I'm going to ask you something. Why did I set it up with them on top of each other? Right, because it makes it easier. Okay, do you want to use substitution or elimination?
Elimination.
I like it. Elimination. Okay. Elimination, what do we look for?
Times.
Opposites. Do we have opposites right now?
No.
No. Next, what do I look for? If I can make one into the other, do we have that option? Yes. Are y'all looking at this 5 and 10? Okay. What do I need to multiply this bottom one by? 2. Why do you say -2? So you can make it opposite. Yep. So I'm going to multiply by -2 to create opposites. So my top equation stays the same. My bottom equation goes to -10p minus 6w equals, thank you, -170. Now we can do our elimination. What happens to the p's? Cancel. So we're left with w equals 15. That was kind of nice, right? Okay. Now we have inequalities, but what do you notice about these two questions? The inequalities, what's the form that they're in? They're in the slope-intercept form. Remember, they're in that y equals mx plus b. So looking at 13, are they both in that form right now? Yes. Remember, bless you, remember they're inequalities, so we have to be a little bit careful. Okay? We graph them the same. Where do I start if I'm graphing this one right here? 2 on y-axis. Where do I go from there? Up 1 over 2. Go throughout the whole graph. Okay, can I just draw my line? Why not?
It has to be done.
Right. Why does it have to be dotted? Because it's not an equal to. Okay, so I'm going to come over here. If we have one of these two, it has to be dashed. And if we have these, it is solid. Okay. So we already decided this one is going to be a dashed line. What is the one other thing we need to do with inequalities? Arrows. Okay. I like to do it one line at a time so I don't get lost. Okay, so this one, it says it wants all the y's greater than. So is greater than, am I going to shade up or am I going to shade down? If it's greater than. Yep, I'm going to go up. So I'm going to put arrows up just to remind myself for later. So another note, I'm going to write, if it's greater than, I'm going to arrow up. If it's less than, I'm going to arrow down. Okay, let's do the other line. Where am I going to start for the other line? On the y-axis, good. And then what's my slope? 3 over 1, so I'm going to go up 3 over 1. Remember, go throughout the whole graph. And then is it solid or dashed? Dashed. Okay, again, do we care about where it crosses? No. Okay, we care about the shading this time. On this blue line that I have up here, it says all the y's that are greater than. So am I going to shade up or am I going to shade down? Up. So I'm going to shade right here. Am I done? No, why not? Yep. Now, the reason for the arrows is because we're going to shade where they overlap. What section do the two arrows overlap at? The top left, right? These arrows right here overlap with these arrows. So we're going to shade this whole section right here. So that section there is my solutions. Right? If we have two parallel lines and my arrows are going in opposite directions. Okay, so that would be a no solution. What would infinite solutions look like? What's that? Yep. So you can have them on the same, remember with infinite solutions on the other, they were on the same line and they went two opposite directions. Okay, I see what you were talking about. So this would be your infinite. So that's if the whole graph is shaded. Okay, so reason I talk about this, I just want you to keep in mind if they don't happen to overlap and you don't have an area to shade, that's okay. Okay, and if the lines are on top of each other and they go opposite directions, that's okay too. Okay, just keep in mind those different outcomes that you could have. Okay? Looking at number 14, are those in the form that we want? No. What form do we want to get them in? Slope. Yep. So I need to get them in the correct form. So I'm going to take my top equation, x minus 2y is greater than or equal to 6. I need to get y by itself. What do I need to do first? Subtract x on both sides. So we have negative 2y is greater than or equal to negative x plus 6. What do I need to do next? Divide by negative 2 to everything. What's going to happen? Y. Yep, I divided by a negative, so that means my original sign needs to flip in the other direction. So then I have, what is my slope now? Tricky. What is my slope now after I divided? Yep, slope turns to 1/2 x minus 3. So remember here, there's still a 1 in front of that x when you divide. Okay, so we have this equation. I'm going to go graph it. So we start at that negative 3 on the y-axis, and I go up 1/2, and go all the way through. Solid or dashed? Solid. And then do I shade up or do I shade down? Yep, because it wants all the y values less than, so I want to shade down for all my less than values. Okay, that one's done. Let's move on to our second equation. I have 5x plus 2y is less than or equal to 6. First step I want to do, subtract 5x. So I have 2y is less than or equal to negative 5x plus 6. Last step, divide by 2. Does the sign flip? No. Didn't divide by negative, so we don't have to worry about the sign flipping. Why do I want to leave my, why do I not want to change 5 divided by 2 into a decimal? Because you're graphing it, right? You want the rise over run for your slope. Okay, so I'm going to start at my positive 3, and then I'm going to go down 5 over 2. Do we care about where they cross? No. Okay, so dashed or solid? Solid. Draw your line. And now am I going to shade up or am I going to shade down? Down, yep. And then the last step is to shade, check where they overlap. Where do the arrows overlap? At the bottom right here, yep. So we shade this area right here.